All right, we are going to sum up every single thing we know about sequences in this nice little summary chart. Okay, so for arithmetic sequence, we have what is called a common difference, which means we are adding. And we use D as our variable. Okay, if D is negative, that corresponds to subtraction. And so if D is greater than 0, adding. D is less than 0, you're subtracting. Okay, for geometric sequences, we have what's called a common ratio, and we denote that with R. Okay, and so ratio means multiply. And so if R is bigger than 1, it's multiplying. And if R is less than 1, so it's a fraction between 0 and 1, that means divide. So we always refer to multiplication, but if you're multiplying by like 1/2, it's going to get smaller. We saw that with exponential decay. Okay, and so for the recursive formula, we get to the nth term by taking the previous term, n minus 1th term, and adding whatever D is. For geometric sequences, we'll use G instead of A. G sub n, we can get to the nth term by taking the previous term and multiplying it by R. You can use a dot. I wouldn't use X for multiplication because that represents a variable sometimes. And so G times R, the previous term times R. Okay, and so we have to know the previous term for recursive formulas. For explicit formulas, which we like better, we just need to know the first term. And so the explicit formula takes the first term and adds whatever n minus 1 is times D. And then the geometric formula, the explicit formula for geometric, if you want the nth term and you have the first term, be careful, that's not the 0th term, you would have to multiply R by the first term n minus 1 times. Okay, and so as a function, we know that arithmetic corresponds to linear, and we can have a shortcut for finding the explicit formula if we know the common difference is our slope, and then we just add the 0th term. And so that's very important. Notice the difference. In this shortcut version, I'm going to use yellow, I have the 0th term. In this unsimplified form, I have the first term. Okay. For the geometric counterpart of this, this corresponds to an exponential function. Whenever you have a constant multiplier instead of a constant difference, it's exponential. And so we have a better formula, or a simplified formula, that takes the 0th term, multiplies it by R, and then raise it to the nth power. We also seen this, I'll do that in just a second, but just be careful. You do n minus 1 when you have the first term. You do n when you have the 0th term. And so I want you to note that. First term, 0th term. And what I mean by 0th term, it's the term that is not given. So if you have a list here, you have to find the 0th term in a sequence. It's not going to be given. The first term they give you is term 1. If you want the 0th term, you have to continue the pattern backwards. Okay, and so in function notation, we saw this as a times b to the x. We saw this as y equals mx plus b. Okay, and so here, d corresponds to m, n corresponds to x, a sub 0, d, n, a sub 0. This would be g sub 0. This would be r, and then our x would be n. Okay, and so let's just do one example of each to have on our summary chart. Okay, here we are adding 3. So this is arithmetic. And so for the recursive formula, we would have a sub n equals the previous term plus 3. For the explicit formula, we would have a sub n equals the first term plus n minus 1 times the constant difference. For the function, we would have a sub n, and we know that the slope or the common difference is 3 times n, and then we would have to figure out what plus 3 gave us our first term, and that would be -7. And so in function notation, instead of using this a sub n, they may even use function notation, f of n. N is your input variable, but it would be the same equation. Okay, for this geometric, to get from 20 to 10, it's dividing by 2. From 10 to 5, it's dividing by 2. From 5 to 2.5, it's dividing by 2, meaning it's getting cut in half. And so we know the constant multiplier would be 1/2 each time. We're multiplying by 1/2 each time. Okay, and so for the recursive formula, we would have g sub n equals the previous term times 1/2. That time makes it look, that one look like an I, so I'm not going to put that times. Okay, for the explicit formula, we would have g sub n equals the first term times r to the n minus 1. And then lastly, for the function or the simplified formula that I prefer, we need to find the 0th term. What times 1/2 would give us 20? 40. So we would start with the 40 and then just use n. Okay, lots of colors. Keep this for your notes.